Hello, everyone, and welcome back to the Tony Livins podcast. I'm Tony Livins. In our last episode, we explored whether artificial intelligence can actually reason. We looked at how AI solves problems, make logical connections, and why reasoning is different from consciousness. Today, we are shifting our focus from language to vision. We are going to answer a fascinating question. How can a machine look at a picture and know what's in it? How can your phone unlock when it sees your face? How can a self driving car recognize pedestrians, traffic lights, and road signs? How can AI help doctors detect diseases from medical scans? The answer lies in a field called computer vision. Let's get started. As humans, we often take vision for granted. You can look at a photograph and immediately recognize people, animals, buildings, or even emotions. Your brain performs this task almost instantly. But for a computer, an AI image isn't a picture, it's simply a collection of numbers. Every image is made up of tiny squares called pixels. Each pixel contains color information, usually represented by red, green, and blue values. A single high resolution photograph can contain millions of pixels. To us, it's a beautiful image. To a computer, it's a massive grid of numbers. So, how does AI make sense of all those numbers? It learns patterns. Imagine showing an AI one picture of a cat. That wouldn't be enough. But what if you showed it a million pictures of cats? Different colors, different breeds, different angles, different lighting conditions. Over time, the AI begins recognizing the patterns that frequently appear in cats. It doesn't know what a cat is in the human sense, but it learns the mathematical features that distinguish cats from other objects. One of the first tasks in computer vision is image classification. This means the AI look at an image and decide what it contains. For example, is this image a dog, a bicycle, a tree, or a human? The model assigns probabilities to different categories and selects the most likely answer. This technology powers many everyday applications, from photo libraries that organize your pictures automatically to apps that identify plants and animals. But sometimes identifying the object isn't enough. Imagine a self driving car approaching a busy street. It doesn't just need to know there's a pedestrian somewhere in the image, it needs to know exactly where that pedestrian is. That's where the object detection comes in. Object detection identifies both what an object is and where it is. The AI draws a virtual box around each object and labels it. For example, pedestrian, traffic lights, stop sign, bicycle, vehicle. This allows autonomous systems to understand complex environments in real time. Another well known application is facial recognition. When you unlock your smartphone using your face, computer vision compares the features of your face with the stored information. It analyzes characteristics such as distance between your eyes, the shape of your nose, the structure of your jawline. If enough features match, the phone unlocks. It's quick, convenient, and increasingly common. However, facial recognition also raises important questions about privacy, surveillance, and ethical use. As AI becomes more capable, society must decide how these technologies should be used responsibly. Computer vision is also transforming healthcare. Doctors increasingly use AI to analyze x rays, CT scans, and MRI images. The AI can highlight suspicious areas that may indicate diseases such as cancer, pneumonia, or diabetic eye disease. It is important to remember that AI doesn't replace medical professionals. Instead, it acts as an additional tool that helps doctors make better informed decisions. The final diagnosis still belongs to the trained healthcare experts. Another exciting area is manufacturing. Factories now use computer vision to inspect products as they move along production lines. The AI can detect tiny defects that might be difficult for humans to notice consistently. This improves quality, reduces waste, and increases efficiency. Agriculture has also embraced computer vision. Farmers use drones equipped with AI powered cameras to monitor crops. The AI can detect signs of disease, identify weeds, estimate crop health, and even predict harvest yields. By spotting problems early, farmers can make better decisions and reduce unnecessary use of water and pesticides. Of course, computer vision isn't perfect. Images can be blurry, lighting can change, objects may be partially hidden. Weather conditions like rain, snow, or fog can make recognition more difficult. Even humans sometimes struggle to recognize objects in challenging conditions. AI faces similar challenges. Researchers continue developing models that are more robust, accurate, and reliable. Another challenge is bias. If a computer vision model is trained on a dataset that lacks diversity, its performance may vary across different groups of people or environments. This highlights the importance of using representative data and carefully evaluating AI systems before deploying them in the real world. Building fair AI isn't just a technical challenge, it's also an ethical responsibility. Looking ahead, computer vision will continue becoming more capable. Future systems may better understand three-dimensional environments, recognize human actions more accurately, assist surgeons during operations, and help robots safely interact with the physical world. Combined with advances in robotics and artificial intelligence, computer vision will play a major role in shaping the future. So, what have you learned today? Computer vision allows machines to interrupt, interpret visual information. Images are converted into numbers. AI learns patterns from enormous datasets. It can classify images, detect objects, recognize faces, assess doctors, improve manufacturing, and support agriculture. Although these systems are incredibly powerful, they still face challenges involving accuracy, fairness, and real-world complexity. Like every area of artificial intelligence, computer vision continues to evolve rapidly. Understanding how it works helps us appreciate both its remarkable capabilities and its current limitations. Thank you for listening to episode 13 of the Tony Livins podcast. I hope today's episode helped you understand how artificial intelligence learned to see the world. If you enjoyed this episode, I really appreciate if you subscribed, shared it with someone interested in AI, and left a review. Until next time, this is Tony Livins. Take care, and I will see you in episode 14.